We were just saying, we've posted the Module 3 assessment. What we'd like to do today is conduct some brief review on the topics we covered related to encryption and ciphers on Wednesday. We just want to make sure that everyone's aware of how the public-private key pair method works, when you would use which type of key to encrypt or decrypt something. And then we'd like to segue into some initial review, a light review of network exposure. And so what we'd like to do is give you a preview of coming attractions for our last class on Monday. So what we'd like to do is have a mini module on network exposure on Monday, and we'll start to demonstrate some of those concepts before we clear today. Please remember that the Module 3 assessment your first attempt needs to be logged by the start of class on Monday. Any questions about those expectations? Some students answered symmetric, some answered asymmetric. Symmetric means the same. And so if Bob and Susan were using one key and it was the same key to encrypt and decrypt, Bob and Susan would be sharing the same key and just one key. That one key would both encrypt and decrypt the messages back and forth between them. But that's not the scenario that we talked about. The scenario that we talked about was that Bob and Susan were taking advantage of this newer idea that they would have a public and a private key pair, right? They would have a pair of keys, one public, one private, and they would use those public and private keys to encrypt the information that's passed between them. The answer to the question is asymmetric. The word asymmetric means not the same, right? So whenever you see the letter A in front of things like typical and atypical. So typical would be normal, atypical would be not normal, right? So symmetric means the same, symmetry, same, and asymmetric means not the same. So the type of encryption that's being used by Bob and Susan are asymmetric methods, okay? Are any questions about that? Okay. So Bob are you ready for the next question?
Yep.
Okay. So what I'm going to do is ask the question verbally, then I'll pause the recording, then I'll post two simple words, right? And I'll ask you to respond again with a one-word answer. So Bob has a public key and Bob has a private key. And Susan has a public key and a private key, okay? So Bob has his own private key and his own public key. And those two keys are not the same, but similar. They're related, they're complementary. Has anyone ever seen the yin and the yang symbol? The Chinese yin yang symbol?
Yeah.
All right. So would you say that each half of this symbol are exactly alike or kind of like similar and related?
Similar and related.
Similar and related. That's what the asymmetric keys are like. It's not one key that's identical exactly. You have two different keys. One is private. That could be like the blackout key, right? Only one person has that key, right? And then there's the public key. So you ready for the question now? So Bob has a public key and Bob has a private key that was created for Bob to use. Susan has a private key and a public key for Susan to use. Now, before they start sharing information, either Bob or Susan has to share one of their keys with the other. Which key will Susan share with Bob? I can ask the same question in a different way. Which key will Bob share with Susan in order to be able to start sharing encrypted information? Will Susan share the private key with Bob or the public key with Bob? Will Bob share the private key with Susan or the public key with Susan? I need you to go ahead and open up the chat window and respond private or public to that question, okay? All right, so I'm going to record this part again. Bob has a public key and a private key that were created for Bob to use. Susan has a private key and a public key for Susan to use when working with others. Bob has to start sharing information with Susan. Susan has to start sharing information with Bob. One of them needs to share one of their keys in order to start the process. The question is, which will they share with the other? Will Bob share his private key with Susan or his public key with Susan? The same question can go the other way. What will Susan share with Bob? Will Susan share the private key with Bob or the public key with Bob? Which? So everyone answered public key, and that's correct. When Bob is sharing with anyone other than Bob, right? I mean, it's kind of crazy, but if Bob is dealing with anyone else, he's dealing with the public. So Bob is going to use his public key to give to Susan. And that the reverse is true. Susan is going to give her public key to Bob. So let's pretend that both Bob and Susan have given each other their public keys. Okay? And now Bob has Susan's public key and Susan has Bob's public key. All right? Is everybody with me?
Yeah.
When Susan is encrypting the message she is sending to Bob, she's going to use Bob's public key. She's going to use Bob's public key to encrypt the information because he gave her his public key. And as long as she has his public key and encrypts the message, when Bob receives it, he can use his private key to decrypt it. It's not the same key that encrypts and decrypts. See, that's the whole piece of the asymmetric that works differently. When you work with symmetric encryption, Bob and Susan only have one identical key, and they have to use the same key to encrypt and decrypt on both ends. So they have to be careful about how they exchange that key if anybody else gets it. Like if they send it in an email, you know, or they put it on a thumb drive and the thumb drive gets lost. If somebody gets that symmetric key, they can read anything that Susan encrypts and anything that Bob encrypts with that one key. That's what symmetric key encryption or single key encryption, that's how it's a problem, okay? But what's confusing to most people is that in order for Susan to send to Bob, she doesn't have to use her private key. If she has Bob's public key, she can encrypt her information because who is she going to send it to? Now think about this. Let's say that Susan only wants Bob to read it. If she takes Bob's public key and encrypts it, the only single key that can decrypt it, Bob has. So if Susan's message is intercepted by everybody else out there, they have a copy of the encrypted message that Susan is sending Bob, but it was encrypted with Bob's public key. And they have the same public key. Bob gave out his public key to everybody. Bob puts a little link on his website that says, here's my public key. Or he could put out a certificate. Does everybody remember you can like put your public out there with a certificate? Yeah?
Yeah.
Okay. Now the confusing part for most people is realizing how this can work in either direction for either action, encryption or decryption, as long as someone has the right key. So if, let's say Bob sprinkles his public key out there with everybody, and it's on his website, and you can even download his certificate out of there and extract the key. And so you have, Bob is like Johnny Appleseed, and he puts his public key out there, right? Well, when Susan wants to send something to Bob so that only Bob can read it, Bob is the only one that has his private key. There's only a single private key. And the only one that has the single private key is Bob. So when Susan's encrypted message is intercepted by everybody else out there, and they try to decrypt it, they have the public key. They have the same key that Susan used to encrypt it. And you can't use the same key to decrypt it. If you use the public key to encrypt it, you have to use the private key to decrypt it. Now let's flip that. This is where it gets interesting. You can use the private key to encrypt something. So let's say Bob wants to send something to Susan, and Bob wants to be sure that Susan knows it's coming only from him. Are you with me? How many copies of the private key are there? There's only one copy. There are many copies of the public key. There's only one copy of the private key. So Bob takes his one private key, the only one that exists, and he encrypts something, and he sends it to Susan. And he says, this is straight from me. And Susan wants to prove that it's straight from him. Okay? Now, what happens if other people out there try to impersonate Bob and they have Bob's key? Do they have Bob's private key or his public key?
The public.
The public key. So they say, I'm Bob, and Bob is bad, and Bob did wrong, and Bob's going to get you. And so they're trying to incriminate, or they're trying to destroy Bob's, what? His integrity, the way people rely on him. People do bad things to each other. So they send something to Susan, and she has what from Bob to decrypt that message? Bob's
His public key.
Yeah, his public key. Can she decrypt that public key encrypted that public key encrypted message from another person using the same public key from Bob? Nope, she can't. It's the yin and the yang, right? So when Bob sends an encrypted message to Susan using his private key, and it's the only copy that anyone has, exclusively Bob, when other people try to read that, they can read it because they have the public key. But if Bob sends it straight to Susan and Susan goes, I wonder if this is Bob, she takes his public key, and if it is Bob, then she can decrypt it and she can read it. Because the only one it could have come from was Bob. Now, if she can't decrypt it, it's not from Bob. Does that make sense?
Yes.
Let's say that Susan needs to send something to Bob, and she has to be sure that only Bob can read it in confidence. Okay? So Bob is the only one that should be able to read it. If you want to figure this out easily, and you hear that there's only one person that's supposed to be able to see something that's confidential, it has to be that person's public key that's used to encrypt it, because when it's decrypted, it has to be the private key. There's only one copy of the private key.
Okay, yeah, okay.